this is question 15 from the St. Paul's 2023 paper. So it's towards the end. It's not the really, really hard questions because some of them carry about 6 or 7 marks. But this one's quite an interesting question, which I think it actually deserves more marks than the paltry 4 marks that it's given. And the question reads, a right angle triangle has its shortest side of length 13. And the other two side lengths are both positive integers. Find the perimeter of the triangle. So we know that it's a right angle triangle. The shortest length is 13. Oops, the shortest length is 13. And we need to find the perimeter of the triangle. So we need to find the other side. So it's right angle, and they're positive integers, so they are some form of Pythagorean triples. Now, if you know your Pythagorean triples, where the 13 is the shortest side, great on you. But if you don't, and I don't, I most certainly don't, and even if I did, I wouldn't be able to remember for an exam, then we have to do something else. And quite honestly, even if you did remember it, you wouldn't get the marks because it's not just the answer, it's the kind of like the workings and the logic behind it. And at first glance, it's like thinking, well, what can I really do? Well, if we just go back to our Pythagoras and we'll say we're a squared plus b squared equals c squared. And that's really what we're going to do. So we're going to write that, well, 13 squared plus b squared equals our c squared. And at which point people are going to say, well, you've got two variables, two unknowns, and only like one number and one equation. There is no way that we could work this out. That's true to a certain extent, but there are other mitigating factors which actually allow us to work it out. And you'll see what I mean. So if I, well, 13 squared is 169, plus b squared equals to c squared. And now I'm just going to rearrange this to 169 equals to c squared plus minus b squared equals 169. Now, because this is a scholarship paper, students are expected to know the difference of two squares. And so 169 equals to c minus b and c plus b. And I'll just do the difference of two squares is that when we have x plus y times x minus y equals 2, if we open up the brackets, we'll get x squared plus xy minus xy minus y squared, which equals to x squared minus y squared. And because these two cancel out. So students are expected to know the difference of two squares for the St. Paul's scholarships. And not only that, but they're expected to be creative with it, such as this question here. So then you're thinking, well, still the same problem, right? However, we are told that b and c are positive integers, so they're positive whole numbers. And we use that. Well, what is these two numbers multiplied? Well, they're equal to 169. These two are whole numbers that multiply to 169. What are the factors of 169? Well, where does 169 come from? Well, it comes from 13 times 13. So it could be 13 times 13 equals to c minus b and c plus b. Or because it's made out of two prime numbers multiplied by each other, the only way it could be is 169 times 1 equals to c minus, c minus b and c plus b. Now, which one makes more sense? If this is 13 times 13, well, then that means that this has to be 13 and this has to be 13, if they're to be whole numbers. But if you have c minus b and c plus b, and they're both equal to 13, the only way that can happen is if c is 13 and b is 0. But that just doesn't make sense because it's just not a triangle. So it cannot be this case, which means that the other case, well, must be c minus b, c plus b. Now, because both of these are positive integers, which one is going to be the 1 and which one is going to be 169? Because these are both positive integers, the c plus b must be the larger one. And the smaller one must be the c minus b. So actually, we've got two equations now. C plus b equals to 169, and c minus b, well, equals to 1. So now we actually do have a pair of simultaneous equations. And if we add them together, we'll get 2c equals to 170, which means that c must equal to 85. And then because the difference between c and b is 1, then it means that b must be equal to 84. Which means that this equals to 84, and c equals to 85. And if we add them all up, well, we know that, well, these two, c plus c is 169, plus 13 equals to 182, sorry, 182. So it'd be 13 plus 85 plus 84, so it gives us 82, 182, sorry. So even though we started off with a scenario where we have two unknowns and one equation, if you know your difference of two squares and you're creative with their use, and you can reason out the fact that, well, 169 can either be 13 times 13 or 169 times 1, and this one cannot possibly be the case in the context of this triangle, which means it has to be the other case. And if you happen to know your Pythagorean triple of this and this, well, you could write it straight down, but I'm pretty sure you'd only ever get 1 mark for the final answer. Well, I think this deserves a bit more than 4 marks, to be honest.